Yeah, ciao Svima. Hi everyone. I'm really glad to see you all here today in Sarajevo, and I hope you had a great day today. Hope you had a great morning, and I really hope you you had a chance to try out the local cuisine. But I really sure hope you haven't tried already burek sa sirom, because if not, good luck trying. Anyway, we have a topic to discuss today, which is going to be a security-related one. Do you remember what the internet looked like 15 years ago? Oh, and I think that screen is not working properly. Anyways, yeah. Twitter already existed 15 years ago. MySpace was still relevant, and it also let us edit our own CSS and HTML as well. We didn't have Discord, Telegram, Viber for any sane community management. Surely we did have IRC of some sort, but that's not the same thing, is it? What we did have was a lot of forums. So if we had a fandom, we probably had a forum. If we had a game server, we probably had a forum. And if we had some hobby club, we also had a fandom. The web landscape was really full of smaller scale web pages, portals, forums. It still is kind of full of them, but we have to understand that we've really moved a lot of traffic to centralized platforms. And the difference here is that, unlike centralized platforms, smaller scale websites do not have multi-million-dollar web teams, and they cannot really allocate a lot of time working on security. And so it wasn't really uncommon to see a defaced website back then. Like, in some cases, you would be able to see a website defaced because the owners somehow lost their access to the FTP. But sometimes, and those are the vulnerabilities that I abused in the past, sometimes we actually had a way to inject the scripts into the page. And just imagine, you're visiting a forum, you see that the introduction section has a new message. You try to open it, and there's a guy named Igor who's introducing himself. And that's actually what is happening right now, because we're on a forum and I'm Igor. So, hi everyone. I'm Igor. I came here all the way from Belgrade. It was a 5-hour ride. The toughest part was crossing the border, actually. I'm a software developer, linguist, I sail, what do I do? Sometimes I ride bikes, sometimes I paddleboard, sometimes I ski. And feel free to approach me to talk about linguistics, try to be software architecture, software engineering in general, or processes, or just basically anything you feel comfortable with. I'm somewhat shy, so I might not talk back too much. I'm gonna talk back. But yeah, back to our forums. You read my introduction and decide to reply. But once you press the reply button, what you see is that. The click. So, instead of replying, you get rickrolled. How did that happen, you might ask? And the answer is, as cunning as I am, I managed to inject the script into the page, which just decided to override the onClick handler and redirect you to the specific video on YouTube. And rickroll isn't really the worst thing that can happen to you during those breaches, because people might try to steal your session, they might try to steal your data, they might want to act on your behalf. And there are a lot of security expertise in the field, and so it's generally not something that we do. Like, we don't really let people insert arbitrary code into our pages. And so today it's really significantly more difficult to find such a page that would let you pawn it like that. And here's what changed. Firstly, we moved to more centralized platforms. Those platforms have a lot of money, they have a lot of people, they have a lot of expertise. Back then, Stack Overflow wasn't even popular. It did exist, it was gaining popularity, but we cannot say that we had as many developers working with it. Then, we as developers have better tools. Like back then, we can argue that people didn't use frameworks as much. Frameworks might not have been popular. People sometimes didn't know better. And so to sanitize the data, it had to be an explicit decision made by developers. Right now, it's pretty much the default. So better tools. And those tools actually got better themselves at sanitizing the data. So, and the last important piece of that security is that the browsers got better. Right now, we cannot really see a lot of HTTP sites, unsecure HTTP sites. We have Cores, which is not really giving me a pleasant experience usually. And those technologies are what brings me here today. My talk is not going to be about nostalgia. It's going to be about one of those technologies, which is content security policy. That's the standard which helps us limit the damage which occurs when bad actors actually manage to inject something into the page. And to really understand how it works, we got to take a quick look into the way browser pages work, and we have to look into the way browsers actually load the pages. And the most important thing is that the browser, when it returns a page, the server does not return the images. It does not return the fonts, styles, whatever. What really happens is that the browsers read the document and then they go and fetch it. And usually it happens indiscriminately, but with CSP, we actually have a way to control which sources are going to be loaded. And to illustrate that idea, let's imagine that we have a landing page with user testimony. So here's the question. Where would the images come from? What are the valid sources for logos, user pictures, other images on the page? And usually we will have a couple of CDNs. They will be accessible through certain domains, and that's pretty much all we're going to have that's going to be valid. And since we know that we will only host images on those few sources, we can probably say that any other domain is invalid. So we can tell the browser to reject it, because we know it cannot be our content. So to do that, all we have to do is add a special header to the server response, which specifies that valid image sources are the ones that we want. So, and if we try to add any other kind of image, something that doesn't match that policy, the browser's not going to load it and it's just going to reject it. The same principle applies to fonts, images, workers, manifests like media, styles, well, a lot of kind of contents. If the server returns a policy which defines which sources to respect for that kind of content, the browser will respect that policy. That technology is available in pretty much every modern browser. I'm looking at you, Safari. And it's really becoming a part of like security certifications, and it's really becoming a part of our everyday lives. And so it's only natural that we will hear about it more and that we'll see about it way more frequently, way more like in volume. And we will also see it in our tools. Like if you've started a new Rails project in the past 3 to 4 years, you have probably seen a new initializer which suggests a policy. And the same goes for Roda. It has a plugin for content security policy, and it suggests a policy which is a bit stricter than the one that Rails has. And when I'm talking about strict, I have to really specify what strict means. And the thing is, strictness is a spectrum because it's really difficult to somehow define precisely, because like we have a lot of different factors, we have a lot of different viewpoints, but we can probably say that a less strict policy only blocks blatantly bad content, and stricter policies will be difficult to overcome and will require attackers to attack other parts of your infrastructure and get there. We can have an analogy that is somewhat useful, not precisely technically correct in ways, but helpful in some ways. So imagine that we have a house with a garden really close to a forest. A lovely place, good neighbors. You don't really need a fence to secure yourself from anyone. But then you realize that there are hikers in the area, there are some animals, critters, and you get annoyed that they just walk from the forest and go through your yard. So that's like not having CSP at all. Then you have an option to just put a fence on the farthest place of your plot. And so that will deter some of them, that will actually stop some of them from going. Surely people can still walk around it, people can still hop over the fence, but it still reduces the amount of how many of them will go through. Like the most blatant way to walk is going to be closed. Then you have an option to extend the fence up to your front yard. Surely people can still walk around it, but it will make them walk through the most populated area of your plot. That's the area where you spend a lot of time in. And, well, you have a higher chance seeing that something is going wrong here, and you can probably stop them. That's like limiting the domains. And surely there is the next step. You can just fence the whole plot and make sure that everyone who goes in requires your explicit permission to enter. And that's the strictest level of CSP that there is. That is the same level of CSP that is in the talk. And that is the same level of CSP which caused me around 4 months of really intensive work and a lot of emotional support from my fellow colleagues. And that's probably what we're going to talk about next. And here's confession time. We've come really close to the nerdy part with a lot of code and not a lot of memes. And on top of that, the second part of the talk is usually my weakest spot in some ways. So I brought you something that will make it worth your while, hopefully. Now, you can use your laptops to feel what precisely I'm going to be talking about. I actually built a website where you can check out various kinds of CSPs. I've created a couple of small attacks, so to speak, and you can test them again for kinds of policies. You will be able to review the attack before it happens, and you will choose how precisely you're going to expose yourself to it. And yeah, you're free to add your own attacks to test them out. You can just have some fun, and I'm going to take the website down in 2 weeks. We can actually have a little fun to demonstrate. Basically, let's do the recrawl. So we can see the policy that we currently have in the browser. We can have the code that's going to be injected, and we can see it with different kinds of We can see them with the console. The console is where it's at. So when we launch it in strict dynamic, why does it? There is a filter, yeah. And then security policy of your site blocks some resources. So yeah, that's what happened. We didn't load jQuery, which is realistically. But then if we have no CSP, what's going to happen is that I click anywhere on the page and it redirects me to YouTube. So yeah, that's how it works. You can feel free to. And now I decided to play the music on my laptop. Right. Oh no, thank you. That's not going to be needed. Right. That's the link. Feel free to open it, and I'm going to take a sip. Right. Back to our policies. Our goal today is to introduce the strictest policy to an existing project. I'm talking about existing projects because that's probably what we are working with usually, because when the project has the requirement to add CSP, it's usually been living in the wild for a few years. We can also say that it has acquired some kind of legacy, it has acquired some tech debt, and so it's not going to be as easy as interaction in greenfield projects. So we can start with default Rails policy. It produces a fairly permissive policy, but still blocks some kind of content. So let's go ahead and see what exactly it will block. When we're dealing with complexities of CSP, we're usually more interested in scripts and styles and not in other kinds of content. Usually, and I emphasize when talking about complexities. That is because other kinds of contents is usually somewhat straightforward. There are not too many ways to include other kinds of content, and there are a lot of ways to include scripts and styles, and a lot of variations, a lot of security considerations too, because those are probably the most powerful tools that we have on the pages. So that policy blocks inline CSS and inline JavaScript. So if we had just something sitting in the attributes, it's going to be blocked. So if we had scripts in the attributes, they're going to be blocked. If we had inline styles, they're going to be blocked in the attributes too. Then what's not going to work is eval. It's been a while since I saw a new JavaScript library which uses eval for anything but source maps, but they're still there in the wild. They might have been added back when the project started, like 5, 6 more years ago. And so that's going to be blocked too. Then we will lose access to regular inline JavaScript, but only if they come without a nonce, or if they come with the nonce which doesn't match the one provided in the header. And when we're talking about nonces, we have to understand that a nonce, along with the hash, is basically the way for us to say that that script is definitely added by us. So the nonce means that the script is added by us, the proper nonce only. The server returns the policy and it specifies which nonce is valid for the page. Well, and so every nonce on the page must match the one sent by the server, and otherwise the browsers will reject it. And I can see the screen is rejecting my talk right now, so we'll probably wait a little bit until that part is resolved, because it's really, like, you know how chess grandmasters can play chess in their minds? It's not only grandmasters, but people who are proficient in chess. I have my utmost respect for them. And yeah, I don't really expect you all to do the chess in your head, especially with Ruby code, especially with all of the layers of complexity that there are. So yeah, that's going to happen. Next. So, back to our sheet. So, the header returns a nonce. The same nonce has to appear in the script. So if the script is not accompanied by nonce, or is accompanied by the one which doesn't match the contents, it's going to be rejected. If an inline script or style contains the nonce which matches the header, it's going to be valid. I usually recommend using built-in helpers in the Rails because they just support that out of the box. So this policy is really fine for new projects, but it will break something for older ones. And let's work on that. What we're going to do to make our lives easier is to run our testing straight on production. It usually sounds scary, but we have a nice way to do so, and it's here. You can see the last line changed. So that's the thing which we can do with content security policy, is that we can run it in the report only mode. So it will pretend like it's a proper policy, but the browser will not reject it will not reject anything. So if we combine it with the functionality of reporting, we will get a lot of valuable insights. We will see what exactly is broken in our platform without anyone noticing that something is wrong. So we have a lot of monitoring tools. We have generic ones like Datadog, Sentry, Raygun, and then we have CSP-specific ones like Report URI, Casper, I think it's pronounced. What to choose is up to you, but please consider that those CSP-related tools also give you tools to improve the policies. So there are two separate things you might do with them. So once we've implemented that, we will have to wait a few hours or a few days to collect enough data, because that's just, we need to get the real user load to see where exactly the problems are. And then we will play the game of whack-a-mole. I found an image which doesn't really look like a mole. It's more like a French bulldog, but that's whack-a-mole, the game. They pop up and then you hit them. So what will you probably find? The first one is sometimes we use HTTP instead of HTTPS. We're going to have to fix that. Then we will see that Safari images loads images from blob, which is weird, but that's what Safari does, so we will have to extend our policy to allow for that weird use case. Evals won't work, so we'll have to rewrite. We have inline JavaScript and the attributes and the links. We actually have a way to allow that, to add an exception to the policy, but we can just rewrite those. Then we will see some dependencies that are broken, some inline scripts are going to be broken, so we'll have to update them in some way, or we're going to have to replace that, and we're going to have to do a few iterations of that. And that's going to take some time. That's going to take a while because, well, practically it is a game of whack-a-mole after all. So the new issues are going to be popping up, the new weird issues are going to be popping up, and we are going to have to fix them. That's pretty challenging, but that's probably not rocket science. The process itself is not rocket science, but sometimes the fixes are not that far from it. So once we've done that, we will be safe from that kind of free crawl, because we are not allowing any inline scripts, but you might have noticed that we allow any script from HTTPS. So where should we go next? We basically have two options. We can either constrain by domain, or we can go all the way towards strict dynamic. When we constrain by domain, we have multiple benefits. Well, the first, all we have to do is to collect all the domains that are going to be listed in our apps, localhost, stagings, Docker, CDNs, and we have to just put the list together and insert them. We need to also match some kind of security, but that really provides adequate level of security, because as long as those domains are within our possession, we will probably be fine. Then the fun thing is that the monitoring services, the CSP-specific ones, they can generate the list for us. They can generate the policy by observing the reports, and it's really quick to implement. But the thing is, is not really so simple, because we need to make sure that we cannot load scripts from the same domain that we upload files to. We need to make sure that those domains are either under control or are trusted by us. Then we have to deal with third-party scripts. We need to somehow make ways not to forget, and then we need to make sure that we don't have some unsafe technologies. And with strict dynamic, the scripts will not load unless explicitly allowed by a nonce. Any script is not going to be loaded. That's kind of transitive, because we might have a question. So I have a script, it loads some other scripts. How do I pass the nonce to them? And the answer is you don't have to. The browsers deal with that. And I think, at least reasonably, the proper way to overcome that kind of policy is to do man-in-the-middle attack, which is rather bad for you. So either way is going to be a heavy attack. So, and it might be easier in the long term. But it requires us to add scripts in a very specific way. It also requires a lot of labor to address all the single scripts in our application, because we have to target the place where it's being added. Then it might be problematic with Hotwire. There are a few issues with Turbo specifically, and it really is extremely difficult with static pages. When I'm talking about adding scripts in a certain way, we just have to make sure that everyone uses the same way to add scripts, which is usually the Rails helpers, and they have to remember to put in the parameter. It doesn't have to be this way. A while ago, I submitted a proposal to do that, to fix that, so that if we have strict dynamic, the nonces should probably be added automatically. I don't really have the energy to pursue that endeavor, but if you would like to join or you would like my help with that, just ping me and we'll do it. So, one of the last things about the real complexities, we have scripts on static pages. When we have a static page, we have a static HTML. We don't have a server which generates the HTML for every single response. So, in this case, we can probably say that we cannot add any nonces to the scripts. So what shall we do? One of our options is to calculate the hash of the script. That's tricky if you do not control the scripts, or if those are bundled, or that requires a lot of heavy machinery. And especially if you add external scripts, that's not going to be viable. So there's one weird standard solution, is to take all of the scripts, or take some of the scripts on the page, group them together by URLs and parameters, and then write another script that will add them to the page. That's weird, kinda, but that really works. That really works really well in some cases, until it doesn't. That's actually the reason I spent 2.5 months implementing the policy, because we were using Next.js and it uses server-side generation. And so we have static pages, and so we have to deal with that. In theory, with React, it's going to be easy because you have virtual DOM, you can do all sorts of rewrites, but in reality, it's really, really heavy. So the alternative to that solution is to just add another level of proxy, because if you have a CDN, you usually have edge functions. If you don't have a CDN but have a proxy, like traffic, you can have a plugin that rewrites the contents. And so you can put some kind of placeholder and replace it. And you'll have to do that in both header and the body. But the risk here is that it might be a vulnerability, potentially, if someone learns about your specific placeholder. So, yeah, you have to think about it. So, There are a lot of things I can say about CSP, but not a whole lot I can say in an interesting fashion and while also meeting the time limits that we have. So let's wrap this up and see what we've achieved. Well, firstly, the overall idea is that CSP helps us against cross-site scripting and all sorts of injections, data injections, like image injections. And the way it does it is it limits what kind of content can be successfully injected. If you want to introduce CSP to your project, you can start with Rails default policy and iterate from that. Just run it in the report only mode and use report URI to get the insights into what's going wrong with the project. And then you will have to fix a lot of issues, and it's going to take some time and it's going to take some effort, and you're going to get exhausted at some part of that journey. And then when you have to go further, you have two options. Either go to limit the domains, or you can go towards strict dynamic and allowing every single script explicitly. And when doing that, make sure you weighted the pros and cons of each approach. Like, generally, it might be easier to go for domains, because if you have an SPAs, then adding strict dynamic might be way too much effort. And if you're using Rails for front end, there are issues with Hotwire that you will have to fix yourself. And once you've done that, make sure to enjoy your time here in Sarajevo. And that's it. Yeah. Thank you.